Probe Data Analytics Suite User Group web meeting today. As I mentioned, we are looking to have quite a few folks participating today. We'll see, given the big nor'easter, if that's going to, hopefully folks will be able to join in. As you know, this is not being done in listen-only mode. Therefore, we're asking that you please mute your line until you're asking questions. The speakers will give us an opportunity after each presentation. Joanna? Oh, I'm sorry. Hi, sorry. Yes. So the call-in number's on the screen. You can call Justin for any difficulties at 484-557-7009. Please, at this point, if you can mute your computer. Also, we're going to have, as it's shown in blue, we're having a lot of folks participate in this web meeting, so please mute your line unless you're asking a question. And this web meeting is being recorded, and all materials will be available after the web meeting. At this point, I'm going to turn it over to Kelly Wells, one of our user group co-chairs, and she's going to host our meeting today. Thank you, Kelly.
Very good. Thank you so much, Joanna, and welcome to everyone who's joining us today. Like Joanna said, we have a large list of folks that have signed up for the meeting today, so I hope everyone will be able to join us. We have two wonderful presentations today and then an opportunity for agency input, so I look forward to some really good discussion at the end of the meeting, and I know you will enjoy the two presentations. So go ahead, Joanna. Here are the agencies that are participating. If you would take a look, and if your agency is not indicated there, will you unmute and let us know who you are?
Hello, this is Shawnee Danlin. I'm with FEMA Transportation.
What was the first word?
Shawnee, S-H-A-W-N-Y, Danlin, and I'm with FEMA Transportation.
Okay, very good. Welcome.
Thank you.
All right, is there any other agency not on our list?
PA Turnpike.
All right, Pennsylvania Turnpike. Oh, there it is, PA Turnpike Commission. Yeah, you're on there. Anyone else?
Virginia DOT.
Virginia DOT. You're at the very bottom right, Virginia DOT and the Research Council. Anyone else? All right, well, wow, what a great cross-section of agencies we have today. Go ahead, Joanna. You'll see our agenda. Oh, please make sure that your line is muted. Like we said, you want to mute your computer as well and just listen on the phone. And when you're not speaking, mute your line using *6. Go ahead. All right, so first we'll start with a coalition update, and then we will talk about our spotlight presentation. I saw a run-through of it. It's a really interesting presentation on some of the enhancements that PennDOT has sponsored to the PDA suite, and then we'll hear from the CAT Lab about what's new and what's coming soon, and then we'll get to dig a little bit into the bottleneck ranking tool, which is always something that I find very, very interesting. Then we'll have our agency input session, and then we'll wrap up and talk about our next meeting. So with that, I believe I will turn it over to Denise Marco with the I-95 Corridor Coalition. Denise?
Thank you, Kelly. Here we go. I just wanted to give you all a little bit of an update on some of the recent meetings that we've had, and then as well as some meetings that are coming up. The reason we try to do this, from whether it's a user group, whether it's a workshop, whether it's an exchange, is so that if there's something on this list that you see that you think might be of value to your agency, and you want to forward that information to someone within your group, that's the reason we try to do this outreach. We're finding that there's many people who want to hear about certain things, but they're not on our existing member list.
So any attempt that I can make to get this information out to you, I do. So on January 18th, we had a RITIS user group meeting. We talked a lot about some of the MAP 21 measures that are coming forward and some of the requirements. Michael Pack is now hosting both the RITIS meeting and the PDA meeting. So if you have any questions, he is always the go-to guy for that. January 25th and then back on February 27th, we had a coalition steering committee meeting on the 25th. What that is that there are members of each of our program tracks, our TSMO, our intermodal freight, our innovations, and some of our executives that are starting to work on developing a strategic vision and a work plan for fiscal year 2019. We have we have a strategic planning session coming up next week for the TSMO program, but the idea is to start to bring back to the members more of what you want to have done. We also did an executive board strategic planning session with the secretaries, directors, and commissioners up and down the corridor last week as part of the Washington briefing. And again, we wanted to hear from them what was their vision moving forward, not only for us, but also for your agencies. And so as we move through our program tracks for our strategic planning, we plan to share that vision with you all. January 29th, we're starting to go back to something called biannual validation meetings. What that means is that for agencies that purchase probe data, I hear some background. Could somebody please mute their line? Thank you. The biannual meetings are such that we're trying to take probe data, validate it along special facilities now. We're moving back from not just freeways and arterials, but we're starting to look at managed lanes, tunnels, and special facilities for validation. So we're going to start to reinvigorate and regenerate that as a biannual meeting. We had in January, end of January, beginning of February, something called a Southern Hogs Exchange. And what that was, it was the states of Florida, Alabama, Georgia, and the Carolinas, and many of the director and executive levels came together to talk about the strategies that were being used for Hurricane Irma. They opened up the shoulder, the emergency shoulder, or the shoulder for emergency shoulder use. What was right, what went wrong, how do we get better at it? Next hurricane season, what do we do? So bringing together commissioners, directors at that high level so that they can then roll down some of the initiatives to middle management. We held that at the end of January. And lastly, we had a volume and turning movement steering committee meeting in February. We're getting some great results. This is the attempt, if you are not aware, where we're sponsoring research to look at how we can take probe data, which gives you speed data, but also look at how it might be able to provide volume data. We've had some good results on the freeways. We're looking at arterials, and we're also looking at low volume roads. So there is another steering committee meeting set for January that's coming up, and hopefully we will have more, even better results as we keep getting better at it. For the update, for the meetings that are coming now moving forward, we have a heavy towing workshop. Unfortunately, it was scheduled for March 2nd. It's being postponed to the end of March. And that's a follow-up to a workshop that was held in December to talk about how in incident management, how do we get better at integrating tow operators into that whole process, because they many times are a group that we don't automatically think of when we talk about incident management. I mentioned our strategic planning session that's coming up next week. It's done in conjunction with March 15th. Next Thursday is the Traveler Information Annual Meeting, where the groups get together. The morning sessions talk about trucker information and trucker travel information. That's becoming more important, I think, to many agencies, is that movement of freight on our network. And then we're having an agency roundtable where there's an update by agencies of what they're doing new and maybe innovative and how they're improving the traveler information. April 19th, we're having a work zone monitoring tools national webinar. We have 3 of our agencies. We have Penn Turnpike. We got Michael Pack with his work zone monitoring tool. We have Transcom with their Spadal tool that are providing us with a webinar on how those tools are being used in work zones. And then finally, at the end of April, we're having a computer-aided dispatch data integration workshop at the Maritime Academy in Baltimore. Many states are now getting to the point where we're looking at CAD integration. How do we do it? What are the caveats in grabbing information from state police? How do we get it out there? So that's a 2-day workshop being held at the end of April. So as you can see, There's a lot going on. But the purpose of this is to say, if you know of someone that you think might be interested in this, shoot me an email. I'll be glad to send them the information. So with that being said, I think I'm going to hand this back to Kelly. You want to introduce Michael?
Yes, I will.
Okay.
Steve, right?
Thank you.
I'm going to introduce Steve.
Or Steve's next. Okay. Go ahead.
Right, Joanna?
Well, actually, I'm going to do a little bit first.
Oh, sorry about that. Go ahead, Michael.
Well, so while we're going to talk about what's on the horizon a little bit later, we are going to jump into a few new things that's been going on with the suite, and it's going to help set the stage for what Steve and Mark are going to talk about later. So we've been busy. We've been working on something called an API. I'll talk about that in a second. We've been doing a lot of documentation updates, some Map 21 updates, trend map modernization, bottleneck ranking features that are new. We're going to hear more about that later, and other minor bugs and enhancements. But I want to draw everyone's attention to this Probe Data Analytics Suite Application Programming Interface. This is brand new. It was funded by PennDOT, and you're going to hear more about it in a few minutes. This is really for users who want to develop their own applications. You know, they like the measures that are in the Probe Data Analytics Suite. They might like the visualizations, but they want to start doing their own thing. If you have any sort of computer programming skills, you can go in and you can write code that then allows you to reach out to our databases and query the database for the same types of performance measures that you get through the suite, but you're doing it programmatically, and then the data comes back to you, and then you can put that in your own application. So this is brand new. PennDOT's been testing it and helping us to fix any little bugs that they find. And again, you're going to hear more about it from Steve in a few minutes. So if you're interested, reach out to us. Some other things we've been doing, Map 21, the subpart G has now been enabled. So if you have your speed limit data that you want to provide to us, we can integrate that into the system for you, and then you'll be able to see the annual hours of peak hour excessive delay per capita. We've also done some additional work to enable multi-year Map 21 visualizations. So now you can look at 2015, 2016, and 2017 and beyond. If you have access to a prior year's data, you'd be able to do that. And there's all sorts of other little Map 21 additions that we've made recently. I've got some clarification from Federal Highway on how they want average vehicle occupancy to be handled and volumes to be handled. So updates made recently. So we encourage you to go back in and use these tools to look at your PM3 measures. And just a reminder about that, for states that are already purchasing RIDIS and the Probe Data Analytics Suite, these Map 21 tools I just mentioned, those are available to you right now. You don't have to do anything special other than make sure you signed a data sharing agreement for getting access to the NPM-RDS data. Otherwise, that's there and it's available for you. So please use it. So other work we've been doing, we've gone in and we've been modernizing different aspects of the suite. The one we focused on most recently was the trend map. So that's the animated maps that allow you to compare multiple geographies or multiple date ranges for a geography. This no longer requires the flash player. It uses significantly less memory. So what that means for you is that you can now load in more TMC segments, and you can have finer granularity. So going from an hour temporal resolution down to 1 minute or 5 minute or 15-minute data, all that can be handled now in the trend map. And we've also added this new chart down at the bottom, which is our percent readings over time chart. So this breaks down the speeds into different bins. So how much of the time are the speeds between 0 and 19 miles per hour versus 20 to 39, and so on and so forth. And as you play the animation, the chart ticks along, and you can see how the speeds are broken down for the geography that you selected. So all that's new. Make sure you go and check that out. And then we've deployed quite a few new features and functionality to the bottleneck ranking tool. Now, most of these features were deployed prior to the last user group meeting, but we admittedly didn't do a great job of explaining what some of those new features were to folks. Most of these features were, again, funded by the Pennsylvania Department of Transportation, so thank you for that. And you're going to hear more about some of these changes in a minute from Steve, but then Mark Franz later on is going to go in depth, and he's going to show you what has really changed in this tool. So are there any questions about anything that I've mentioned thus far? And feel free to speak up, or you can type something in the chat window. See someone typing something, so we'll give it a minute. All right, well, maybe we don't have any questions. If you think of anything, just type it in, and we'll come back to it a little bit later.
Okay, thank you so much, Michael. So now we will get on to our spotlight presentation by Steve Galt. And Steve is a traffic project manager for Michael Baker International. He's serving as a consultant to PennDOT for development of traffic operations metrics program. He's a licensed professional engineer in Pennsylvania and is a certified professional traffic operations engineer. He has more than 14 years of experience in engineering in both the public and private sector. He has supported PennDOT traffic initiatives including TSMO, Greenlight Go, TSAMS, Automated Signal Performance Metrics, the Traffic Operations Performance Metrics Program, and Autonomous Vehicle Research. So please help me welcome Steve.
All right. Well, thank you, Kelly, and good morning, everyone, and thanks for being here. What I wanted to focus on this morning is reviewing several of the things that PennDOT sponsored. Michael kind of went through a couple of those already, but these have all been deployed in the PDA suite, and wanted to make sure everyone's aware that they're there and how we're using them and how hopefully you'll be able to find some value as well. And the driving force behind these enhancements is PennDOT's goal of establishing a performance metrics program. Historically, decisions on how to address congestion were made anecdotally with little, if any, data to support them. We may have used a one-day count or knew it was bad because maybe an agency employee regularly drove through an area. But as big data becomes available for the transportation system, we know we can do better. And the goal of PennDOT's metrics program is to analyze the data that we already have to answer congestion-related questions. So with that in mind, the metrics program focuses around 3 areas. First, we need to identify congestion, where, when, how intense, how reliable, and then that forms the baseline picture of where we are. Next, we want to understand why we have congestion by classifying congestion into buckets like physical bottlenecks, traffic signals, incidents, work zones, weather, and special events. Knowing why leads us to what mitigation strategies are appropriate, and then brings us back full circle, and we can do a before and after comparison of when and where and how intense, how reliable, and see how we've done improving over time. So the enhancements I'll be discussing today are focused in the identify congestion area and answer 4 basic questions about congestion. How intense is congestion? How reliable? When? And where? We focused on several metrics to answer these questions, including time delay and delay cost, as well as indices based on travel time, planning time, and buffer time. And although identifying key bottlenecks isn't quite a metric by itself, it's also an important tool to help answer the questions and some of the metrics that come out of the bottleneck tool. So as we talk about that, the when and where congestion exists, it's important to recognize that each of those dimensions vary. And to visualize variation, it's easier to hold one of the dimensions constant and visualize the variation in the other dimension. For example, if we hold time constant, we can see a map of where congestion is occurring at that time. And if we hold location constant, we can see a timeline of when congestion occurs at that location. So the trend map tool that was just talked about in the PDA suite is a great tool to visualize where congestion is occurring at any snapshot in time. And the timeline within the bottleneck tool can be used to see when congestion occurs at a particular bottleneck. And this provides a preliminary screening to differentiate recurring from non-recurring congestion as well. So the enhancements that PennDOT sponsored were really focused into 3 areas. The first one is the calculation of metrics to answer those congestion identification questions, as well as the enhancements of the bottleneck metrics. The second area is ensuring that the graphics that are produced from the PDA suite would be suitable for inclusion in reports without needing to export the data to Excel and have to create our own charts and graphs. And we built several customization options into the charts for that purpose. And then finally, we've probably all experienced that working with large amounts of data can be slow, and we want to generate similar metrics on a recurring basis. While these things can be done through the PDA suite, it can be very time-consuming to have someone go in, remember to configure all the proper settings for the analysis, and then wait for the metrics to be generated, and finally save the results. And that's where the API, or application programming interface, comes along, which lets us automate everything that can be done in the PDA suite. And I'll start with the trend map and kind of use that to talk about some of the metrics, specifically the travel time index, buffer time index, planning time index. And as Michael mentioned, the trend map now allows the data to be grouped in buckets as small as 1 minute and up to 1 hour, and even combining multiple days to compare results. So for this example, I pulled some Friday afternoon commute traffic in the Philadelphia area. First, just a basic speed map that shows there was some areas that had some slower traffic, which wouldn't be that surprising. When we look at the travel time index, and what this is comparing is the median to the 50th percentile speed, and in many of the segments, the speeds at that time were more than 2.5 times the free flow speed. Moving into the planning time index, this starts this compares the 95th percentile to the free flow speed and indicates how much time should be planned for a trip along any segment in order to arrive on time 95% of the time. And what this map's showing us is that many of the segments require planning for more than triple the free flow time in order to make a Friday night trip. Then when we look at the same time period with the buffer time index, this is comparing the 95th percentile travel time to the average travel time at that time of day and day of the week. And it's really an important measure of reliability, because how does this particular Friday compare to most Fridays? So if we remember back, it took 3 times the free flow speed to travel in many areas. But when we look at the buffer index, it's actually a pretty typical Friday afternoon on most of the interstate network. There are a few locations with a higher buffer time, which is most likely an indicator of some type of non-recurring congestion, such as a work zone or an incident. And finally, with the trend map, one thing just for those that weren't aware is in the upper right-hand corner, there's the little Save button, and all the data can be exported to Excel. And whatever time interval you're using, each interval will actually show up with all of the metrics. There's a tab in the spreadsheet for each of the metrics that can be shown on the map. And one of the key things is just to make sure that it saves as an XML file. If you right-click and choose Open With and then open it in Excel, it'll show up as a normal spreadsheet. The metrics can also be visualized as graphs, which is useful for aggregating multiple road segments together to see how the overall network operates, such as portions of an entire county or maybe all roads of a certain classification in the state. And have a couple examples of that. This shows the planning time index. Again, it's calculated the same way as what was shown on the trend map, but it's aggregating, in this case, looking at all of the interstates in Pennsylvania on a particular day. And just, an insight we can draw from it is that this is the same time period we looked at for those trend maps in Philadelphia, but where it was 3 times or a 3.0 in many areas of the Philadelphia region, the rest of the state really balances it out, so it's only about a 1.2 is the worst case. As I noted earlier, the graphics can be customized, and there were some new features added there, including the font size, the colors, the titles. We found that using a larger pixel size, which is at the top center, and a transparent background gives the best quality for a printed report if they're saved and exported. This example shows changing, so I think the default color scheme is an orange, and this just shows changing it to a red for a buffer index. And there's different ways to visualize it as well. In addition to comparing the time periods within a day, the charts can also compare different days of the week. So for this example, I limited the results to the PM peak period between 4 and 6 p.m. and compared the different weekdays for an entire year. And it's quite interesting to see that congestion is really building throughout the week, especially on the north-south interstates in Pennsylvania, which are the orange and green lines. And if you struggle remembering how to explain what a buffer index is or a planning time index is, there's also an option to include the definition as part of the chart that is exported. This particular one shows the buffer index over the same year as the previous slide, and also shows that reliability is getting worse throughout the week, in addition to just the planning time index. And finally, we get to the bottleneck ranking tool, and I guess Mark's going to have some more detail about it, really, but I would say this is one of my favorite tools in the PDA suite. But first, I think it's important to understand how the bottleneck tool works. So a bottleneck exists whenever the speed drops below 60% of the free flow speed. So a freeway with a free flow speed of 65 miles an hour would be considered to have a bottleneck starting whenever the speed drops below 39 miles per hour, and then ending whenever the speed comes back up above 39 miles per hour. Bottlenecks have a head location and can grow or shrink upstream of that location. The reported queue length represents the length of the adjacent TMC segments which drop below the 60% threshold to be considered a bottleneck. Going back into the past, the traditional metric for ranking bottlenecks was the impact factor, which considers the time duration of the bottleneck and the queue length. However, this doesn't consider how severe the congestion was. If we go back to that example with a 65-mile-an-hour freeway, a bottleneck where the speed is 38 miles per hour would have the same impact factor as a bottleneck where the speed was 5 miles an hour. Likewise, a bottleneck on a road with low volume would have the same impact factor as a bottleneck on a road with high volume. To solve this, PennDOT and the CAT lab worked together to develop new metrics which would quantify how severe the bottleneck is by the speed differential as well as the volume. And this resulted in the total delay measure. And it's important to note it's not really a true delay number because of the computational complexity to produce an actual delay, but it's a close enough surrogate for delay that it provides a good tool to rank the bottlenecks and compare them against each other. And as many of you are aware, you can rank bottlenecks by clicking on any of the column headings in the ranking table. And again, going back to the issues that I was mentioning about the impact factor, I would strongly recommend clicking the total delay column to rank the bottlenecks this way rather than the default, which is ranking by the impact factor. And our experience has been when we rank by the total delay, the list is pretty reasonable, and we were getting some logical results when using the impact factor. And this shows when we rank by the total delay, the top 10 I think are all within the Philadelphia region, as well as a couple, the top 50 that are in the Pittsburgh and Harrisburg areas. As I noted earlier, the bottleneck timeline is a great tool to visualize when congestion is occurring at a particular bottleneck. This example just shows one day, but clearly shows the morning and afternoon commuter peaks on a section of I-95. But then if we expand that and take it into a whole month, we can start to see a lot more patterns and trends. And in this case, the morning peak is very consistent on work days. So we can see the weekends, we can see Thanksgiving. So this is showing the month of November last year. Black Friday when a lot of people aren't working. But then on the flip side, the PM is much more variable. And when we go back to that buffer index, when I was showing that on the map, this is the section of 95 that had the worst buffer index. So it does coincide that less reliability and the buffer index are all coming together. If we want to do further analysis, we can change the timeline to the elements table, which allows a deeper dive into when the bottleneck was active, again representing when that speed dropped below 60% of the free flow speed. As the queue grows or shrinks to include different segments, there's a separate row in the table as well, so you can see the maximum length would represent how many segments got pulled in. And that can also be exported to Excel for additional analysis. There's also another visualization in the bottleneck tool, which is the element graph. And this provides a combination of the timeline view along with the queue length. And we can see one of the things that I found interesting looking at this situation is in the morning, the queue, it's not congested at all, and then all of a sudden there's a 6-mile queue, almost instantly. And then you can see it clears out, from the end back towards that beginning again. But then in the PM, it builds much more gradually. So it's, different things that we can start to look at to understand what we might want to do to address that. If we have a queue that's building very fast, do we need to look at some messaging that's going to make sure that drivers are alert and that our traffic management centers are monitoring that to prevent any incidents with that queue building so fast. So the obvious question at this point is how are we integrating this into our processes and the things that we're doing on a regular basis? And as I noted earlier, we want to move from anecdotal to data-driven decision-making. One of the first areas we're doing this is with our regional operations plans, which in some areas haven't been updated for over 10 years. And these plans serve as the initial planning document to identify what projects we want to deploy to address congestion. And our goal is to give planners the ability to layer congestion data with other data via a mapping tool to understand how the congestion is affecting things and what possible mitigation strategies would be appropriate considering TSMO-based solutions. And to do this, we're using PennDOT's OneMap platform, and I do have a link down at the bottom there. It's just onemap.penndot.gov, and this is live now. Right now, we're starting with the central region of the state, which is PennDOT districts 2, 3, and 9, and we're trying to pull in the bottleneck data and show where those are. So the orange lines here represent the top 50 bottlenecks in the central region that are ranked by total delay. And I think for this analysis, we took a 12-month period, so we're intending for this mapping to update monthly with the previous 12 months of data so that seasonal variations aren't affecting the overall results. And then using this and zooming in, we can then click on an individual bottleneck and see the attributes. Again, things that are coming out of the PDA suite, such as the delay, which in the API is still known by a working term of delay surrogate. Some of the other ones, I couldn't fit them all onto the screen at once there, but we also are providing a ranking based on some different geographic boundaries, such as PennDOT districts, the regions that I was talking about earlier, and also our planning partners or MPOs. So the mapping tool really brings together the pieces of our metrics program. We start with identifying congestion using the tools in the PDA suite, and then using the map layers, we can start to identify the potential causes of congestion. For example, we can show all the traffic signal locations on a map overlaid with the bottlenecks to see where we have congestion around signals. We can show crash clusters to see where incidents may be contributing to congestion. We can layer weather data such as flooding or winter weather road restrictions to see where weather may be contributing congestion. And we can use active construction projects from the tip as an indicator of work zone congestion. We can also use the mapping tool to screen for potential mitigation strategies. And for example, we have a layer that shows roads with shoulders that are wide enough to support hard shoulder running. And when we overlay that with the bottleneck data, this helps to identify where hard shoulder running could be a solution to congestion. And as I mentioned earlier, in order to make this mapping platform work, we really needed a way to get the congestion identification metrics from the PDA suite to feed into our mapping platform. And the API is the solution for this, and I think the CAT Lab really hit the ball out of the park on this one. When we started, I thought the scope in the contract was a little vague, and I wasn't quite sure where we were going or how we were going to get any use of it when we started, but as soon as I saw the first draft of the documentation, I really saw the potential. And as Michael mentioned earlier, anything and everything that can be produced with the PDA suite can be automated with the API. And the API operates using a web service with JSON formatted messages through a request and response process. And all of those web requests are then tied to an API key, which is a long string of letters and numbers that's tied to a particular user's Redis login. And there are three basic categories in the API. The first is the segment search, which is used to determine what TMC segments meet certain criteria, like how we select roads in the PDA suite. and everything else that we're going to do requires a list of TMCs. So the segment search is really always going to be the first step to generate what TMCs are going to be evaluated. Bottlenecks operate the simplest, and it's going to generate a list of bottlenecks for a given list of TMCs and time period, and then from that, individual bottleneck elements can be requested to have, like that elements table that we saw in the PDA suite a few minutes ago, can be exported as well. And everything else then operates as jobs, which entails submitting a request, checking the status, and once the status indicates it's complete, then retrieving the results. And this works for exports, which is essentially the API equivalent of the massive data downloader, as well as performance metrics and user delay cost. And without trying to get too technical, I just have a couple examples of the API and what it returns back. So this example is a bottleneck, and there's actually more information in here than you can get directly in the PDA suite, including the list of which TMCs are part of the bottleneck. Also seeing, and I had to cut it off in the slide here because it would have made everything too small to read, but there's actually the coordinates of each point along the road that makes up the bottleneck, and that's what we were able to use to then get the bottleneck data into our OneMap platform. And then on the right side, you'll see this is linked. You pull the bottleneck elements for a particular bottleneck ID from up here at the top, and then it has the start time, the end time. The one thing that's here, again, that's not in the PDA suite is the impact speed differential, and that allows us to kind of see which bottleneck elements are really contributing the most to congestion by having the biggest speed drop. Next, we have the Performance Measures API, which is also very powerful and can produce values for as many different percentiles as a user would request. And that's over on the right side here. So in this example, I just picked the 85th percentile and 95th percentile, but it's possible to specify whatever ones you would want and get the results back for those. And one thing here is that you can group TMCs together, or you can have each one return its own results separately. So depending on what type of analysis is going to be done, those results can be aggregated in different ways, also for different time intervals. This one shows a whole day for a whole year for one particular TMC, but there's all kinds of different ways to mix and match time and location through what TMC segments are part of it. And finally, we have the user delay cost, and this aggregates the delay both for an entire day, and as you see the daily totals on the left side, and then there's also hourly data that is returned on the right side. And this is broken out by commercial vehicles, passenger vehicles, and a combined total. So hopefully this information has sparked some new interest with how everyone else is using the PDA suite, and you may be able to try some new things with these features. PennDOT's certainly excited about the opportunity to continue developing and enhancing features within the PDA suite, and with that we can open up for questions.
Okay, so if you'd like to ask a question, please note it in the chat box, or you can press *6 to unmute your line and ask your questions now.
Hey, Steve, this is John from the Turnpike.
Hi, John.
How are you? Hey, I just have a quick question about your grouping. Do you, once you group things, is it automatically always in that group, and you could just keep calling it? Say if you have, if you guys are doing certain corridors, like if you do your 283 corridor, if I do my 476 corridor, is that the group alias you always call for the API?
When you would set up your programming code to call the API, you can really define whatever grouping you want. So as part of the request, and I didn't show the format of the request in here, but you define all of the TMCs and then you give whatever grouping of TMCs a name. So it's really, you know, if you're going to be submitting something on a recurring basis, then you would just submit that same group of TMCs and give it the same alias name every time you would submit it.
Okay.
Hey, Steve, sticking with the Turnpike here, do you also use this for your non-recurring congestion to analyze incidents?
We haven't started doing that yet. One of the things that I'd like to get into is when we start to, we have a kind of our three-step process, but going back to the bottleneck elements table, I think we could probably get to a point where we take each one of these individual elements and say, you know, the first one from 6:21 a.m. to 7:32 a.m. on Friday, December 1st on I-95, start to compare it with some of our other systems and see, was there an incident that we were aware of? Was there a crash that we're aware of? Was there a work zone that we're aware of? And really classify into different buckets each one of these, you know, as a probable cause, and ultimately build the congestion pie chart for any road segment. But we haven't gotten there yet, but I think that having the data in this format gives us the ability to take it to that next level and do that matching.
And I just want to tell you, good use of PennDOT One Map. That was my brainchild before I left. So it's exactly the uses I wanted it for. So
it looks like there was a, speaking of One Map, there was a question in the chat box of whether that's available to anyone outside of PennDOT. And I think the answer is yes. There may be some layers that require a login, but not all of it does. So
it's available to everybody except for some of the maintenance layers. You just have to log in with your email.
Any other questions?
Yes, this is Denise. Can you guys hear me?
Yes.
Okay. Steve, question. Can you explain a little bit, you made a mention about work zones. Can you kind of explain what you're thinking about using this with work zones?
So
go ahead.
If we have a time when congestion starts and ends, there was some reason that there was congestion at that time. And if we link this up with our, in PennDOT's case, we have a roadway condition reporting system known as RCRS that tracks all of the work zones, where they are, when they're active. We could compare, using time and location, the data that's shown in the bottleneck elements table, and then essentially do a process of elimination and figure out, you know, was there a work zone then? Was there an incident? And, you know, we may not be able to come up with a cause for every single element, but I think a lot of them, and I've done a couple manually where I've gone into those systems and pulled data, and I was able to essentially build a congestion pie chart manually by associating different things that we already knew about and had documented at the same time and location. Does that answer your question?
Sure. I was just curious in terms of, and I'm going to actually punt this to Michael, with your work zone monitoring tool that's available now, Michael, is there any cross or overlap with what Steve's doing here?
Well, Steve's really doing, in-house development for PennDOT, custom work. So the work zone monitoring tool is a way for us to visualize some of the performance measures that can come out of probe data and other data elements within RITIS. But I don't know if the suite, the API, and the work zone can really be compared directly.
Okay, thank you.
Michael, correct me if I'm wrong, but right now your work zone tool is more of a real-time tool. It doesn't have the ability to look at the archive data.
Yeah, well, so, if you go into an individual work zone, it'll look back like 7 days, but you're right, it's not designed for evaluating a long-term construction project. It is really real-time analysis. So you want to continue to use the Pro Data Analytics suite or something else for, evaluating the before and after studies for a construction project.
See, I think what we're looking at trying to come up with is how much of our congestion is caused by work zones over the course of time. So it's, there's definitely a benefit to the work zone tool for real-time operations managing a work zone. But then there's also a higher level, program level understanding of how good are we or how bad are we at implementing work zones, and could we do a better job and reduce some of that congestion. And I think that's where the archive data comes into play, and being able to understand how many of the bottlenecks are attributable to a work zone would be useful information.
So Steve, this is Kelly. I'll kind of add to that. I guess, is your RCRS integrated with RITIS?
It is. We've been working through some challenges of how the data feed is getting interpreted, because right now there's some fields that are missing. But ultimately, I think that is part of our goal, is to integrate that, and whether we develop something in-house or we do another project with the CAT lab to develop a classification tool. We haven't quite figured out what path we're going to go yet, but I think...
I say it because one of the greatest time savers for me was when we did integrate our incident data with RITIS, because when I like the spiral diagrams, I can't remember if you showed it in your thing, but on the spirals you can actually see. So I used to manually take my monthly bottleneck report and manually go through and look for, incidents. But then, when we got it integrated, now they just pop up on the spiral diagram. It is a huge time saver for us. You just look at the spiral and say, oh, look, there's a work zone. Oh, look, there's a crash. And it's a beautiful thing. It's really helped us quite a bit. Now, it's not systematic and analytical, like you said. It's kind of more anecdotal. But, I mean, I don't know if you do that yet, but it's been a big time saver for us.
Yeah, it's definitely a good point, and we do, we have it at least to the point where it's showing up and saying there's a work zone or there's an incident, but some of the attributes that pop up are what's missing. So that,
yeah, but at least for us, it tells us there's something there. Go look in your incident system. And before you had to look all the time and figure out if it was, I mean, it's just, seeing that little icon there makes a big difference for us. So I would encourage you to do that if you're not already doing it. All right, any other questions for Steve? All right, so Joanna, can you go to the next slide, please?
Just give me a minute of switching over to the main presentation.
Shall I introduce Mark? Yes. Yes, I shall. Okay, so while she's pulling that up, I will introduce Mark France. He earned his BA in physics and his BS in astronomy from the University of Florida. That's a really neat combination. And his MSCE from West Virginia University, and his PhD in civil and environmental engineering from the University of Maryland, with an emphasis on transportation engineering. Currently, he is the lead transportation analyst at the CAT Lab, where he is developing and improving online transportation analysis tools and visualizations for all of us who get to enjoy them in the PDA suite. So with that, I will turn it over to Mark.
Hi, thank you for the introduction and for the opportunity. Can you guys hear me okay?
Yes, we can.
Okay, great. So I'll be presenting today some of the new features that have been added over the last few months into the bottleneck ranking tool. Steve touched on some of them. I'll go a little bit more in depth on the sort of the features that are new and then illustrate how they can be utilized using a very brief case study within the PDA bottleneck ranking tool. So the topics that I'll cover in my presentation today are the changes to the algorithm. The algorithm itself that has been available for over a year now, and for a while we were giving users the option of using our old algorithm or the new one. Since that time, we've retired the old algorithm and are focusing on the new algorithm. And I'll briefly discuss the advantages of the new algorithm and why we're using that now. I'll also go over the new look and feel of the interface, including the bottleneck ranking table, which includes a few new metrics, again, that Steve briefly mentioned. We'll talk about how we can use those metrics in the case study. And then I'll also discuss the new data visualizations that have been added to the tool. So just to go over sort of the advantage of using this new algorithm without getting way down into the weeds of the calculation. So the old algorithm used to use the average queue length and the average duration of a given bottleneck and multiply that times the number of occurrences that the bottleneck was activated within the analysis period. So if you look at what that would be calculating, it's the area encompassed by the red box in this plot. The new algorithm is a little bit more complex in that it can handle the dynamic evolution of congestion within bottlenecks, which allows us to look at the area under each of these bar graphs, which is a more accurate representation of the queue lengths that are associated with the bottleneck. So related to that, as I hinted toward, the new algorithm also considers the complex evolution of congestion. So to illustrate what I mean by that, I have a few graphics to show the advantage of the new algorithm here. So we can see that on this map and the chart on the right for at a given time, we'll call it time A, that two separate bottlenecks are formed on a given road here. It's I-270 in Maryland. But in either case, you can see that one's being caused by a work zone, and the other one is at this merge area between the two spurs of the I-270. And there's certainly different causes here. So when we do the impact factor, they need to be assigned to each independent bottleneck and not to just one of them. But we can see that as these conditions evolve over time, at some later time B, the queue from location A may merge with the bottleneck that used to be a bottleneck head at location B. So the old algorithm would consider this, all of the impact would go directly to location A, where we know that it actually has some contribution from location B. So it allows us to tease out that information and properly assign the impact to the bottlenecks contributing to the overall queue. So for that reason, again, is why we developed this new algorithm. We feel that it's superior to its predecessor. So a little bit of background on the new metrics that are included in the bottleneck table before I get to showing the table itself. So the base impact factor is sort of what I just described in terms of estimating the queue lengths at a given bottleneck at time intervals that we can sum up over time. So that's what we're calling the base impact, just the summation of the queue lengths over time. So when we start to consider things like the severity of the bottleneck, we look at the speed drop associated with the bottleneck within the queue. So when we multiply the queue length by those speed drops, then we get what's called the speed differential. And then when we take that speed differential times how many people, an estimate of how many people, how many vehicles are being impacted by that bottleneck, we use the AADT, and we get the measure called total delay, which is the one that we recommend for agencies to use in looking at terms of overall cost to society. But that'll be illustrated when I go through the case study. And one other consideration is multiplying the base impact by what's called congestion, or the speed percentage drop. So it's a way of normalizing the speed drop, looking at the activation period of being the 60% speed drop. Of 60% of the posted speed limit is when it's activated. So by normalizing that, we come up with a measure called congestion, which is consistent with what congestion is in our other tools within the PDA suite. So those are the 4 new metrics that I'll talk about: the base impact, speed differential, congestion, and total delay. So this is what the new metrics look like in the new table. So we've changed the look and feel of the table itself, and we're clustering certain outputs as shown here. So as I mentioned, the old algorithm used these bottleneck profile metrics that are provided: the average max queue length, the average daily duration, and the total duration. We also include, as Kelly mentioned, the number of incidents and events that may be, contributing to non-recurrent congestion or making recurrent congestion even worse. So we give some information on that. The base impact factor, which is the sum of the queue lengths, is provided here. Then the other metrics are all the speed differential, congestion, and total delay. We multiply the base impact factor by those 3 to get the 3 new metrics. Another thing that we are providing in the table, which I won't get into too much detail in my presentation, but want to mention it, is links to external links within the PDA suite. So once you've identified the locations of the bottlenecks, we're now providing a direct link to other PDA tools, including performance charts and the UDC tool, which will automatically import the TMCs included in this bottleneck and into those tools so that you can get more details about travel time index, buffer time index, planning time index, and also the user delay cost. So to illustrate how we can use these new metrics and sort of what the new visualizations are in the bottleneck tool, I'm going to go through a case study using interstate data from DC, Maryland, and Virginia. The dates of my query were January 1st through February 5th of 2018. And let's just assume that we want to look at 2 different considerations. We want to look at bottleneck ranking from the individual driver's perspective. So let's say the analyst wants to know what, as an individual driver, if I was in my car driving through these bottlenecks, which one would be the most frustrating for me to sit through, to drive through? So that's that sort of perspective. The other one is probably more commonly used by agencies, and the one that we recommend for agencies for overall engineering analysis. It's looking at the total delay or the cost to society caused by individual bottlenecks. So we'll walk through how we can use the new outputs and metrics to answer those, or look at those 2 considerations. So here's what the landing page looks like. So by default, we're ranking by the base impact factor. So again, that's just the summation of the queue length over time during the activation period for each bottleneck. So note here, we're going to see how this individual bottleneck here, it's ranked number 2. It's I-60 East at US 40. When we use the base impact factor, it's ranked number 2. And we'll see how that changes when we start to sort through the other available new metrics that are out there and why it changes our perspective on it. So just focusing on the table itself for now, let's assume that we change from ranking by the base impact factor to the base impact factor weighted by the speed differential. So this is looking at the severity of the congestion, the raw speed drop at that site. So we can see that when we do that, what was once ranked number 2, the I-68, now becomes ranked number 5. So we can see that the results are a little bit different when we're considering the speed differential impact. So this is starting to give us more insight on the question of, what is the worst bottleneck in terms of the individual driver's perspective. And we can see that when we consider this, our ranking is a little bit different. What was number 2 is now number 5. And then just jumping to the other metric, congestion gives you a similar ranking style as the speed differential. It's just normalized. So I'm not going to go through that one in detail. But if we were sorted by total delay, which is the base impact factor, multiplied by the speed differential, multiplied by the AADT. So it's looking at the societal cost now. How many people or how many vehicles are being impacted by this bottleneck and its severity. And we can see that what was once ranked number 2 in the base impact factor and number 5 in the speed differential factor is now 1,414th when we consider the volume on this road. So from an agency's perspective, looking at a cost to society, they would have this as a very low priority bottleneck. And I'll discuss how this particular bottleneck showed up in some of the as a top ranked bottleneck in some of the outputs using certain metrics, but not in others. We can do that by looking at the various visualizations. So with that in mind, here's one of the map visualizations that are provided in the tool. And we can see that as shown here, using the total delay metric, the 1,414th ranked bottleneck is shown here. We can also see that there was some minor work zones and events that occurred during this period. Nothing too alarming. So it's interesting to see to analyze this more. Why did this come up as a top ranked bottleneck when we use the base impact and speed differential factors? But we can learn more about this when we look at some of the other visualizations that we provide. So here is the timeline chart that we can look at patterns of congestion and also how severe it was. So the colors show the queue lengths at particular times within the analysis period, with the beginning of the analysis period being the 1st of January at the top of the chart, and the end of the analysis period was the 5th of January, with the tick marks being individual hours of the day. So by looking at this, you can see that there's not a real strong pattern of congestion going on that would indicate recurrent congestion, but we can start to see that there are identified very long queues of up to 8 miles occurring during the overnight hours from 8, 9 p.m. till 6 a.m. But during the middle of the day, it's not really there. So we're starting to gain some insight about what might be causing the data to tell us that this is a bottleneck, but maybe it really isn't. So a different flavor of that chart is the spiral chart, which Kelly mentioned she uses to help identify if it's recurrent congestion or what the impact of particular incidents might be. So, looking at this particular bottleneck, we can still see that there's not a really strong pattern going on of recurrent congestion. There's only 2 incidents that occurred during this period. You can see with the yellow diamonds. Neither of them had a huge impact on the overall bottleneck calculation. So, but we can still see, using this chart that from, 7, 8 p.m. till 7 or 8 a.m., the overnight hours, that is when most of this bottleneck activation is going on. So again, using it in the same way to get some insight about what's going on. Perhaps more telling is using what we call the elements chart. So Steve mentioned this. So this chart is one of our newest additions to the bottleneck tool, and it utilizes the algorithm. So as the legend shows, on the y-axis, it's showing the spatial considerations, with the blue bottleneck being the one that's selected. Other bottlenecks that are included in the queue, their ranks are provided here. So there's other individual bottlenecks that end up being in the queue. What we're showing on the graph itself is the number of days is color-coded that it was in bottleneck activation for each hour of the day. And when we sum up this, individual rows for each time, we're plotting what the total congestion was for that hour or the average, I'm sorry, not the total, congestion was, or queue length was for that particular time of day. So again, this is starting to tell us, similar to what the time chart did, that we're having these queue lengths form and grow heaviest at the midnight to 6 a.m. or so, and it dies down in the middle of the day and then picks back up around 8 p.m. So again, the overnight hours seem to be the problem. And then when we look at the total hours of delay, they're summed over spatially and shown on this chart. So we can see that a lot of times being lost as they approach the bottleneck and join the queue, as you might expect, and it gradually dissipates as they get past the bottleneck area. So we can use this to decide, sort of identify what potentially might be causing this. So knowing this location, I personally drive through it a lot. It's in western Maryland. It's a very hilly, mountainous area, and there's a lot of trucks that use it. So it's I-68, which links off of I-70, so most trucks leaving any of the major ports on the East Coast and are heading west or vice versa are traversing this area. So during the night hours, it's mostly trucks, not as many passenger vehicles. Given that it's a mountainous area and we're looking at the analysis period of January through February, a potential cause, you can't say definitely, is these trucks going up and down the mountains, and there might be snow or ice on the road. And if there's few cars out there, that just one or two trucks can actually activate the bottleneck algorithm and make it look like it's a true bottleneck where it's just these heavy vehicles moving through the mountains under winter conditions. So you can't say definitively, but that's a potential cause of what's going on here. And if we didn't have the new metric of total delay, which looked at what's the volume going over this road, it would probably raise more concern than it would otherwise. So it's important to note that difference. And just one other feature of this graph is when you scroll over the visualization, it'll have a tooltip that pops up and gives you more details about that particular time and location. It'll give you the number of days that it was congested, also highlight the bar charts and the total hours, or the average mile bar chart and the total hours delay that are associated with that X and Y coordinate that you're hovering over. So you can learn more about what's going on at any particular time and location if you want more details on it. So you can see here that only 6 of the 36 days at this time and location, very close to the bottleneck head itself, was actually congested. It just happened to be very severe. Again, it's the slow-moving trucks, which sometimes, in the time chart or the time spiral, you can see it came up with 8-mile queues. So that's sort of an anecdotal way to look at what is causing this to happen, but it might be useful in identifying what's going on. So I think, yeah, so that concludes my part of the presentation. I'll be happy to answer any questions that anyone has.
Well, this is Steve called. If no one has a question, I might just provide some things that we've noticed as well. That sometimes the probe data can be skewed, especially in the overnight hours. We came across a case where it was actually reporting historical average speed, and for whatever reason, the historical average speed was really low for one particular hour, and it actually was below that 60% and activated the bottleneck. So it's probably going to be pretty rare that that happens in a low-volume roadway, but something to be aware of and watch out for.
Yeah, that's a great point, Steve. Steve's one of our, he helped us develop a lot of these new metrics and vet it out. So, and he's been using it a lot. He knows the ins and outs of it. So I appreciate the input on that, Steve. Any other questions?
I might ask another question then.
Sure.
The term bottleneck, one of the things that when we put our data out in one map, we got some comments back from users that were saying, well, this isn't a bottleneck, it was a work zone. And as I started to think about it more, I realized that we're kind of using the term bottleneck to mean two different things. And when we classify congestion in the historical pie chart causes of congestion, physical bottlenecks is just one cause. And I think, it always made sense to me what was in the PDA suite, but then I realized how some people may be misinterpreting it to think that it's only finding physical bottlenecks, and I didn't know if that was something anyone else had come across, or if terminology-wise we may want to think of what we call different things.
Yeah, it's a good point, Steve, whether it's caused by, high demand or if there's a physical loss to capacity due to an incident or work zone. I guess that's always been a debate on the terminology, but we would certainly be willing to talk to people if they had other ideas on that.
Yeah, we'd gone back and forth whether we were going to call it like congestion hotspots in the mapping, and ultimately decided against it because we didn't want to use the data from the bottleneck ranking tool in the PDA suite and then call it something different and be telling people, well, we gave you mapping tools, but go into the PDA suite to do a more in-depth analysis, and then it's going to be named something different and cause more confusion. So just food for thought.
That's a good point. Thank you.
Any other questions for Mark? I see someone appeared to be typing. Oh, okay. All right, last call. Any questions? All right, then go ahead. Thank you so much, Mark. That was wonderful. And Joanna, if you could advance the slide.
I think it's back to Michael at this point for the coming soon and then the agency input session, and we have about 15 minutes or so, I think.
All right, go ahead, Michael.
All right. So I wanted to make people aware of a few things that we're working on that we think are exciting. The first is our OD analytics. So we have a new tool that has just been rolled out for the state of Maryland, and my video doesn't seem to be playing here. Shoot. Okay. Well, the video is not working, but on the right, there's supposed to be a video of our OD analytics, which is integrating trajectory and OD data from NREX, and allows you to actually see where people are moving. You can generate OD matrices on the fly. You can filter those matrices based on different criteria. You can even click on individual segments on a map, and it'll tell you for everyone who traveled through that segment, where were they going, or where did they come from in terms of which zip code or which TAZ or which county or what have you. It's a really exciting tool, and I imagine the next PDA user group will do a live demo of this for everyone so they can see it. XD support. We're actively working on integrating NREX XD data into our tools, or at least creating the capability to use XD data in our tools. So this is going to mean finer granularity, finer spatial granularity at least. There'll be coverage beyond TMCs, so you'll be able to see data past just the regular TMC network. It is going to raise the storage cost, so this is not something that we're just going to be able to do for everyone for free, but it's not going to be a whole lot more expensive. It's just going to be a very small increase in the storage to handle that storage and the computation load. But it's going to be very exciting, and that's coming out later this summer. But it's also enabling other neat things. So we've just begun a project with PennDOT again, where they're funding the build-out of some arterial performance measures tools. These tools are based off of the Purdue Signal arterial performance measures tools, building those out and enhancing them in our PDA suite now. And this can make use of the XD data from NREX. So at our next PDA suite user group meeting, we'll have someone from PennDOT give us an update on this project and show all the different visualizations that are being built out. The project won't be finished by the next PDA user group, but you'll get a real solid taste of what all is going to be made available. And I'm particularly excited about this new tool or set of tools. And those are the main things related to the PDA suite that we're working on right now. Kelly, I turn it back to you for input.
Okay, sorry about that. Can you hear me, Michael?
We sure can.
Okay, sorry about that. Okay, so now we have about 10 minutes for agency input. And so as you've been sitting here listening to all of this wonderful content, what comes to mind that you would like to throw out for us to talk about today?
I have a question. Kelly?
Yes.
This is Denise.
Denise.
And I see that New Jersey is on the call, folks from New Jersey and folks from Pennsylvania. And I'm wondering, I'm training myself in terms of congestion management to talk about mobility management. And I'm wondering if, given the road and weather operations, given the snow that's coming down, seems to be never ending, has there been any thought from any of your agencies to look at how you can use probe data to look at performance of your roadways relative to snow operations? Has that been thrown out? I know that up north there's some talk about that, and I'm kind of curious to see if, particularly those from New Jersey and Pennsylvania, anybody, and actually anybody who's interested in this, has there been any thought to that? And I just want to throw that out there. I don't want to call on anybody, but
Denise Solomon, NJTPA. Thanks
Hey.
for the question. From an MPO standpoint, we have not engaged the agencies in that direction or had that conversation, but it is or would be of true value, I'm sure, to all the agencies. I know DOT is on the phone and others, but that's something that maybe we talk about next week during the TISMO work and or HOGS conversation.
Okay.
Denise, this
Hey,
is
Sue,
Jesse from DVRPC.
Hi, Jesse.
Just wanted to chime in that on I've helped in the past. We had, for some of our incident management task forces, in particular the I-95 incident management task force, we had looked at some snow days from a couple of years ago, and just sort of, there was one where there was particularly bad crash on 95 and just some pretty dramatic congestion scans, things like that. But what I would note also is that sort of when you go back and do historical type analysis, you may need to think about some of these months, because if you're looking at a short analysis period and you have a day like yesterday in there, it may kind of really skew some of your results. So it's interesting to sort of look at them as a snapshot and see how things worked in the context of knowing it was a snow day. But, you have to be a little careful that you don't, accidentally use it in a small average sample and get some really weird results that way. And then another thing is I believe there's still under development the option to kind of weed out certain dates manually or select certain dates with the date range tool being upgraded. So I think that would be something that would be really useful for this type of analysis as well, where you could select all of those days that meet your criteria and look at them together.
Okay.
That's my 2 cents.
Anyone else, Mike? Anyone else from Turnpike or New Jersey DOT?
All right. Well, if that comes to your mind, please feel free to reach out to Denise and share your thoughts on that. Sounds like an interesting question, Denise.
It's only interesting the fact up north, Kelly, just to finish, is that we've noticed that when you have weather, the delay tends to increase on all roadways due to road conditions. And so we would bump up a certain amount. If we expected a 20-minute delay with its weather, it would be an additional 5 minutes over a long period, a 4-month period, the winter months. So I was curious to see if anybody had gone down that road. But that's, again, future thought. Thank you.
Yeah, great question. Great. Start to get people thinking. That's great. How about anyone else? Something else you'd like to share or throw out for conversation?
Hi, if none
if there aren't other pressing questions, this is Zoe Niederland from B-Trans. In particular, I'm interested in how people are communicating the results and if anyone is using Esri story maps to put together ways to share results of congestion and other analysis.
Zoe, is that something that you're doing?
Am I unmuted?
I can hear you.
Great. We are working right now on a story map for a large corridor study where we are just exploring how to do that. And then this will be a continuing use of Esri story map.
Sounds like that might be a future spotlight presentation.
It would be far in the future at the moment.
Okay.
And so that requires conflating your TMCs to your GIS system, right?
Yes.
Yeah. Have you done that?
We did it for the corridor.
Okay. I was going to ask Steve, I'll throw that out now. Steve, with what you were talking about with PennDOT, have you done any of that into GIS, or has it all just, I couldn't tell if that one map was a GIS system, or is that just a picture of a map?
The OneMap is a GIS-based platform. What we did to get around the conflation issue is we're plotting the bottlenecks using the coordinate data through the API, and we're not actually, so that if you zoom in really close, they're not going to directly line up with our regular GIS road network.
Gotcha.
But for a visual, it at least allows them to be mapped together.
Right, gotcha. Well, that sounds neat, Zoe, and yeah, certainly a great way to do it. Start with the corridor and conflate that easy enough, and then see how it all plays out.
I can just throw out there, if anyone else is analyzing the results of completed projects using the probe data and trying to use that to understand effectiveness of specific strategies, I'd love to hear about that. We've just prepared a research proposal, and I don't know if it will be funded or not, but it would be helpful just to know if other people are doing that sometime.
Yeah, is anybody doing that, using the probe data to look at the effectiveness of various strategies?
Hey, thanks.
Okay, sure, great question. Again, good food for thought. I do have one question I was going to throw out to the CAT Lab, Michael. I know our MPOs have been excited to use the MAP 21 performance measure widget, and in that you can have MPA boundaries and UZA boundaries, and so the question then came, hey, can we have these same boundaries in other parts of VPP? So I told them I would ask you that question today.
Yeah, I think that's a good idea, and I don't think it would be a huge lift. So we'll talk to the development staff and see if we can make that work in the future.
Okay, great. And we've spent a lot of energy trying to say to MPOs, hey, this is a great tool, you should use it. And now with MAP 21, they're really using it. And then they're saying, well, how come we can't use these other tools? I'm like, oh my goodness, we need to facilitate this. They're there now. They're interested. Let's keep them.
Yeah. I guess one saving feature though is if the MPO, if its boundaries are actual county boundaries, then it's pretty easy for them just to go in and select individual counties in the region Explorer. If their MPO boundaries are not based on county boundaries, then it's more difficult for them.
Right. Yeah. So I was thinking the ones that didn't align nicely with counties.
Yeah, got it. Okay. Well, yeah, we'll look into that.
Okay, great. Thank you. Any other questions or comments or observations?
Kelly, quickly, we only have 1 minute left. Again, this is Solomon in JTPA. Speaking to Zoe's question about evaluating strategies using PDA, We have a TISMO business case project currently ongoing, and we are looking at some of the strategies before and after in the region to try to help make that case. So we're trying to reconcile how this tool and how the data can be used to make that explain TISMO's value in utility. So
That's cool.
So if you'd like our support in that, we're happy to come up and sit down with you and do whatever we can.
I think Kyle Winslow from WSP, who's a consultant lead on that portion, has reached out. So maybe we can have further conversation, Mike, about the opportunity.
Good.
Great. All right, last call. Anyone else like to share an idea?
Now, Kelly, before you wrap up, I just have a couple quick comments. And just
okay, why don't you wrap up and dismiss us?
Okay.
Yes, go ahead, please.
All righty.
And
just a couple
Denise,
quick
this
things.
is Joanna. I have one other thing to say before you end, too. Thank you.
Okay. Just a couple notes. For those of you that are on the call, when you log in, if you've logged in as an agency or just maybe a first name, if there's a possibility you can actually respond back to Joanna or I to who is in the room, that gives us the ability to send you out via the link, when the notes are available, when the presentations are available. Otherwise, we don't really have a way of doing that. And the other reason we do that is because we have a very active member list right now, and we are constantly looking at it, and if we don't necessarily see a person participating over the course of a year and a half or 2 years, we tend to drop them off. And we don't want to do that. We don't want to do that to anyone that's obviously attending these regularly. So please, if you can, give us a shout out to who's on the call, if you're in an agency or just a first name. And the other thing that we talked about, one of the comments Michael has always said is that what he really needs to hear from you guys is features that are not working and what you want for new features. So whether it's via email or on a call, please let us know if there's something that you really are looking for and you want to have added as a new development so that we can start to look at that and move forward. And with that being said, Kelly, that's all I've got. Thank you all, and I'll turn it back to Kelly and Joanna.
Go ahead, Joanna.
Well, Denise must have been reading my mind. I was going to say the same thing. I'd reached out to a bunch of folks during the call, during the meeting through private chat. If you've joined and you didn't necessarily receive this invitation yourself, please just follow up with one of these email addresses, and we'll make sure that you get added to the list.
There you go.
Very good. And were we going to announce the next meeting?